Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Plate with me, Richard here. Yes, today we are looking at this question. It says that, what is meant by electronic configuration? Yeah, what is it? Electronic configuration is the arrangement of electrons in an atom or molecule. So that arrangement of electrons in orbitals in an atom or molecule is what we refer to as electronic configuration. Yeah, then we come to this one, atomic orbital. Yeah, what is an atomic orbital? This is a region around an atom in which the probability of finding an electron is very high, or is the region around an atom where there is a very high chance of finding an electron. Yeah, now we come to this question. It says that consider the atoms below. These are the atoms: potassium, magnesium, and argon. And then the question says that write the electronic configuration of each. And then number 2 says draw the Aufbau diagram for each. Okay, to establish a proper relationship, we are going to answer the 2 questions for each consecutively. To establish a proper relationship, a proper understandable relationship, we are going to answer the 2 questions for each element once. Okay, let's start with potassium. Okay, the atomic number, you have to know that electronic configuration is derived from atomic number, the number of protons, which must be equal to the number of electrons inside the atom. So in this case, potassium has 19 as the atomic number, implying it has 19 protons. And so it has 19 electrons to distribute. So what do we do here? You have to know that the first shell for potassium, the first energy level takes up a maximum of 2 and is called 1. So it's going to be 1s2. Okay, that's the first one. So the second energy level, which is energy level 2, it has 2s and 2p. S takes up a maximum of 2 and the p takes up a maximum of 6. And that one is closed. Then we go to the third energy level, which is energy level 3. It has 3s and 3p. Okay, 3s takes up a maximum of 2 and 3p takes up a maximum of 6. So when you count here, we have this one as 10, then plus this one 18. So we have so far distributed 18 electrons, missing 1, because we know potassium has 19. So the 1 goes to the 4th energy level, which is 4. And S comes first, and it takes up the remaining electron. So what you have here is the electronic configuration of potassium. Then next we go to Aufbau diagram. Yeah, Aufbau actually distributes these ones in the energy levels. Okay, you have to know that the energy level increases as you go up, so it increases in this direction. So in other words, this has the lowest and this has the highest. So we start with the first one. The first one at the lowest bottom, it is 1s. And 1s has 2 electrons, which we distribute as that. On the next level, we have 2s, which is also full. It takes up that and that. Then here, we have to know that 2p is at a higher energy level compared to s. So we put it here. And you have to know that p orbital has 3 subatomic orbitals. That's why it takes up 6. So we have that, those are 2, that's 4, and that is 6. Yes. Yeah, what you have here is 2p. Then from 2p, we go to 3. Yeah, 3 comes here. So it is 3s first. And it takes up 2. But then we go to 3p. 3p is at a higher energy level compared to 3s. And it has 3 subatomic orbitals. So, and it's full. It has 1, 2, 3, 4, 5, 6. Okay. Then lastly, we go to the 4th energy level, which is there. This is 4s. And the 4s has only 1 electron. Yes. So what you observe here is what we call the Aufbau diagram for potassium. Yeah, next is magnesium. The atomic number for magnesium is 12. Okay. So Mg is as a atomic number 12, implying 12 protons, meaning 12 electrons. So we have 12 electrons to distribute. And if we are answering the configuration, what do? You start with the first energy level. It's 1. And 1 has only s, which takes up a maximum of 2. Next one is second energy level, which has 2s and 2p. S takes up a maximum of 2 and p a maximum of 6. When you count here, we have 10 so far. And we are remaining with 2. So we come to 3. That's the third energy level. And 3s takes up the remaining 2. So that is it. This is the electronic configuration of magnesium. And next, we are going to look at the Aufbau for magnesium. Yes, the Aufbau diagram for magnesium, we have to remember that the energy levels increase in this order. So this one has the lowest. So we can have it here. And what comes next and what comes here is also going to be S. Then from there we go to P. PS is at higher energy level compared to S. And it has 3 subatomic orbitals. So we have this, now we are here. Then the next one, we are going to have this one. So when you come to labeling, what do we have here? This one is 1s. This one is 2s. This one is 2p. And what do we have this one? This one is 3s. In distributing electrons, what do we have? This one has 2. with opposite spinning. This one also has 2. Then 2p has 6. Each subatomic takes 2. Like that. Then this one takes up the remaining 2. Yes. So what we have here is the Aufbau diagram for magnesium. Yeah, then we come to argon. Argon has an atomic number 18. And how do you go about it? Let us look at argon, which is 18. 18 is the atomic number, implying it has 18 protons, and the protons are equal to electrons, implying that we have 18 electrons to distribute. And how do we distribute this? We know that the first orbital, or the first energy level, has S and takes up a maximum of 2. The second one it has 2s and 2p. 2s taking up a maximum of 2 and p 6. Those are already 10. Then we go to the third one. The third one is 3s2. That's 12. Then 3p6. That's 18. Yes, this is the electronic configuration of argon. Then next, we are going to look at the Aufbau. Now, the Aufbau diagram, you have to know that energy levels increase in this order. So this one has the lowest and this one has the highest. So we put the lowest here. And from what we see, the lowest has only S. Then the next one is also S. You can put it here. Then you can put the P. P is at slightly higher energy level compared to S. And it has 3 subatomic orbitals. The next one is going to be 3s, which we put here. Then we put 3p here. Okay, so when you come to distribution of electrons, what do we see? This one is 1s, and it takes up 2. This one is 2s, and takes up 2. Then we come to 2p. This is 2p. It takes up 2 in each subatomic orbital. Then we go to 3s. It takes up 2. Then we go to 3p. 3p has 3 subatomic orbitals, and each one takes up a maximum of 2. Yes, what you have here is 3s, and this is 3p. Yeah, so what we have here is the Aufbau diagram for argon. And with that, I would like to thank you for your time. We urge you to subscribe, to comment, to like, to share. Yes, we appreciate you. We believe we are the best. Stick with us. You won't regret. See you next time. Bye-bye.